for your patience. I've been having some, of course, technical difficulties with Zoom and stuff, and I wanted to make sure I talked to you guys about your test. So I want to take you through some of this test, and you can kind of double check your answers if you've already done it, but I do want you to, take some time. This quadratics test is quite extensive, and I do apologize for the length. I'm probably going to revise it in the future, but it has so much good information in it. I think it's important. So let's go ahead and go ahead. So the first thing we want to do is understand the difference between x and y intercepts. So y-intercepts are obviously there's either it's where the graph crosses the y-axis, and I'm going to do this in green so you guys can see it. Okay, so my y-intercept is the 0.03, and we talked about x and y intercepts as it related to lines as well. Now, remember what we're really concerned about, which is why we learned how to factor our x-intercepts, okay? And our two x-intercepts are 1 and 3. Now, because of this, I can now tell you that I know that my factors for this parabola are x minus 1 and x minus 3. Because what I do once I factor a parabola, I set each one of these factors equal to 0 and solve for x. And as a result, I get my x-intercepts, which are solutions. So again, let's remind each other that x-intercepts are equal to solutions. They're also called zeros, and they're also called roots. Okay, and these will be not something you see a lot in geometry, but you'll see it a lot in algebra too. So you want to definitely make sure you hold on to your make sure you hold on to this knowledge and your factoring skills. Okay, so these are real world quadratic functions, and a football's height after kickoff is given by this function, where t is seconds after kickoff and h is the ball in feet. No one catches the ball. How long does it take for the ball to hit the ground? Well, I'm going to show you in Desmos what that means and how we figure that out. The easiest way to do this is, obviously I could factor this out or use the quadratic formula, but when you have a graph that represents the function, you can use those x-intercepts to determine those values. So I'm going to go ahead and show you. This is -6. I'm going to put this into, and I know you guys don't see me doing this yet. Let me put this over here. Plus 15x. Okay, so I'm putting x squared plus 15x. Did we say t? Yes, we did. But in Desmos, we have to use x. Okay, so this is where it starts, and then the function hits the ground again after 2.5 seconds. Okay, so this graph hits a height of 0, because remember, this function right here is where it's time and it gives you the height, right? So we're saying, when is the height 0? So again, that's an x-intercept. So that's after 2.5 seconds, okay? Okay, the revenue from selling a new video game can be modeled from this equation where x is the price of the game and y is the revenue. Find the price of the game that would result in no revenue. So that means revenue is our y value, right? And so we want it, again, where y is equal to 0, which is our x-intercept. So again, I'm going to put this in. It's -3x, sorry guys, -3x squared plus 21x. I know I'm going to forget it if I don't put it in there. Plus 54. Incidentally, when you have this constant at the end of a quadratic, that is where this is your y-intercept, actually. That's where it's going to cross the y-axis, and I'll show you that when I zoom out. See how it crosses the y-axis at 54? So anyways, I think this is a really good opportunity. So how many would they have to sell in order to get no revenue? And that would be at 9. Okay, so let's go ahead. The revenue, find the price of the game that would result in no revenue. That would be $9, I'm assuming. Okay, now let's try another one. Function f of t is negative 10t squared plus 40t plus 120. Models the approximate height of an object after its seconds are launched. How many seconds did it take for the object to hit the ground? Again, we're trying to find an x-intercept. Now we can factor this out and set it equal to 0 if you want, or we can use Desmos as well. So I'm going to go ahead and use Desmos really quick. Or should I? You know what? Let's factor it out. So what I'm going to do is I have negative 10 t squared plus 40t, hopefully I can factor this, plus 120. So the first thing I'm going to do is take out the greatest common factor. So I'm going to take out negative 10, right? And that gives me t squared plus 4t plus 12. Oh, sorry, minus 4t. I didn't use my negatives. So it's minus 4t minus 12. So if I factored this, I would get t minus 6 times t plus 2. Now, we set each one of these equal to 0 and get an x-intercept. So we have t plus 2 is equal to 0. So I'm going to subtract 2. And we get t is equal to negative 2. Well, negative 2 is not a valid answer, right? We can't have negative 2 seconds. There would be some times where it'd be really nice to go back in time, but we can't do that here. So we're going to ignore that negative results, and then we're going to use this t minus 6. So I'm going to do t minus 6 is equal to 0. Okay, and then I add 6 to both sides, and I get t is equal to 6. I probably could have factored this one as well. Looks like I could have. So do you want, I'm going to go ahead and factor it as well. So I'm going to take negative 3 out, and I get x squared minus 7x. 54 divided by 3 is minus, what is that, 18? Yeah. So then I get x minus 9 times x plus 2. And again, we have x plus 2 as one of our factors, so we get negative 2 as a factor, where x is negative 2. Well, we can't have negative 2 be a price. We can't be paying somebody to take our video game. So we're going to set x minus 9 equal to 0, and x is equal to 9. So you could have either modeled these through Desmos, or you could have factored them. This one would have been a little bit harder to factor. I can show you how to do that. So like I would take out a negative 3t, right? And that would be 2t minus 5, right? So I would set negative 3t equal to 0. So t is equal to 0. Well, obviously we don't want, it doesn't hit it starts at the ground there, right? But if I do 2t minus 5 and I set that equal to 0, I add 5 to both sides, and I get 2t is equal to 5. So 5 divided by 2 is 2.5. Okay, so that's 2.5 seconds, and that is where those are. So I wanted to take you through those because those are some really good real life examples, and these things will keep coming up. The other thing I wanted to talk to you about is when you have a quadratic, the number of solutions, again, remember those are x-intercepts. So this guy intersects the x-axis in 2 places here. So there are 2 solutions. There's only 1 here, so that's 1, and this one does not intersect the x-axis at all, so there are 0 solutions. Okay, so we can use our graphing calculator or Desmos, or we can go ahead and use factoring. But let's go ahead and use Desmos for these two. We have x squared plus 5x plus 6. And let me pull that up. Here we go. So we have x squared plus 5x plus 6. So I'm going to zoom in a little bit. Okay. And these are my two x-intercepts. My two x-intercepts are -3 and -2. So those are my solutions. If these are my solutions, then my factors would be x plus 3 and x plus 2. Okay, I'm going to keep saying that because this is something that actually comes up on the SAT as well. So we've got -3 and -2. Now this other one is a little bit harder to factor. So let's go ahead and just put that one on there. We have 3x squared plus 4x minus 2. So let me put that up. 3x squared. There we go. So if I do 3x squared plus 4x minus 2. Okay, so we have two solutions here, and I can actually click on those. And what I'm going to do actually is I'm going to take a little screenshot of it and bring that over, and those will be my solutions here. Okay, I'm going to change that to clipboard. Okay, so they're not pretty. I'm going to paste it. Look how big that is. That's silly. Okay. Sorry. Okay, so these are our two solutions here. Okay. Now, we're going to solve the following by factoring. So when I do this one, I'm going to use the X method that I always use, which is I say what two numbers multiply to 36 and add to 15. And that is going to be, let's see, we've got 6 times 6, 12 times 3, that works. So we've got x plus 12 times x plus 3, and I set each one of the factors equal to 0. So x equals -12, and then x plus 3 equals 0. And I got x is equal to -3. All right. Now, the next one, we're going to take out a greatest common factor first, and that's going to be 5x. So I get x minus 2. So I have two factors here. One is 5x. So I set 5x equal to 0, and I get x is equal to 0. And then I have x minus 2 is equal to 0, and I'm going to add 2, and I get x is equal to 2. So I have those two solutions. Okay. All right, now they want us to factor some more. What the heck? Okay, so when we factor these, remember I showed you this grouping method. I did have this on a video in there, so I want you guys to pay attention to that. So that I multiply this number, and I get -10. And I say, okay, what two numbers will multiply to -10 and add to -3, which is that middle term, which is -5 and +2. So now I take my middle term right here and I split up that middle term and I turn it into 2. So I have 2x squared, and I'm going to use this guy, so I have plus 2x minus 5x minus 5. Okay, and then I just do my quick factoring by grouping here. So I have 2x times x plus 1, and then I have minus 5 times x plus 1. So my two factors are 2x minus 5 times x plus 1. And I set these factors equal to 0. So I have 2x minus 5 equals 0, and x plus 1 equals 0. So I'm going to add 5 to both sides. And I have 2x equals 5. So x is equal to 2.5. And then also x is equal to negative 1. All right. So for number 13, make sure that you take out the greatest common factor first. It'll make life so much easier for you. So you have 3 times x squared minus 4x plus 4. And this is just going to be x minus 2 times x minus 2. Now we can't get the same 0 twice, so we're just going to have 1 0. So it's going to be x is equal to 2. One thing I'd like to challenge you, though, is to also look at your at Desmos and see what that means. It's so important for you guys to understand the relationship between factoring and 0. So we have 3x squared minus 12x plus 12. Let's take a look at that. And then plus 12. Okay, so if you notice right here, there's only one solution, right? Where it hits at x equals 2. All right, the other ones will have 2 solutions if I have 2 zeros. Okay, it'll cross the x-axis twice. All right. Okay, so that's the next one. Okay, so if these are the roots, what are the factors? So if I have a root of x of 3, I have a factor of x minus 3, and I have a factor of x plus 4. Okay, and if I have a factor of 6 or of 0 of 6, I have x minus 6 is one of them. Now what about 1/2? Well, if we look at this, if we did 2x minus 1 as a factor, let's try that. 2x minus 1 equals 0. I add 1. 2x equals 1 divided by 2, 1/2. So this, remember, is the coefficient of the x, and this is the number that's either added or subtracted, and that sign is going to be dependent upon whether or not this is a positive or negative. Okay, so this is going to be x minus 3 times x plus 4. And then that factors out to x squared minus 7x plus 12. Not pretty. Oh, wait. X minus 3x plus 4. Sorry. So that is x squared plus 1x minus 12. And then I have 2x minus 1 times x minus 6. So 2x minus 1 times x minus 6. Now I'm going to go ahead and factor that out. So I do x times 2x is 2x squared, and that's minus 1x. And then that's going to be minus 12x plus 6. So that is going to be 2x squared minus 13x plus 6. Lots and lots of work on this one. This is just kind of a culmination. So solve these for any of your method of choice. Let's go ahead and let's see, 14. Well, let's go ahead and use Desmos. Desmos is our friend. X squared minus 7x plus 14. X squared minus 7x plus 14. So let's put that in there. X squared minus 7x plus 14. Okay. All right. We have no solution here. All right. So this one has no solution. Isn't that nice to be able to graph it? Okay, and then let's do this next one. 3x squared plus 4x minus 20. So we have 3x squared. And that's plus 4x, right? Yes. Sorry, guys. Plus 4x minus 20. Okay, so we have two solutions. Notice this is a really ugly one, right? We could have factored it, but just leave it like this. It's fine. Okay. I'm just going to paste that right there. And these are my two solutions. Okay. All right. So we're going to use 4x squared minus 9 using the following methods. So first thing we're going to do is use the graphing calculator or Desmos. Let's do Desmos first, 4x squared minus 9. So I'm going to do 4x squared minus 9. So here's the thing, guys. We can do this several ways. And this is one of the things. We can use the quadratic formula. We can factor. We can also use a graphing calculator. These are all, none of these are better than the other, but sometimes these methods are easier. One method might be easier than the other. So let me show you by factoring. This is a difference of two squares. So remember, this is going to be 2x plus 3 times 2x minus 3 equals 0. So I have 2x plus 3 equals 0, and 2x minus 3 equals 0. 2x equals negative 3. So I get x equals negative 3 halves, right? And this is positive 3 halves, which is 1.5. So x equals 3 halves. Okay? They are the same because they're the same. It's the same equation. The same equation always has the same solutions. And so I'm going to type this up for you. The same equation always has the same solutions no matter which way you solve it. Okay, identify the x and y intercepts for each. So remember, your x-intercepts are your zeros and your y-intercepts are where it crosses the y-axis. Now here's a big thing. Your y-intercept is always going to be this constant right over here if this is in standard form. So I'm going to write this down. My y-intercept is 0, 5, and this one is 0, negative 5. But we're going to graph both of these, and we're going to also come up with the two x-intercepts too. Okay? So let's go ahead. We've got, what is this? 3x squared minus 8x plus 5. So this is 3x squared minus 8x plus 5. And so we've got a y-intercept right here, and we have two x-intercepts. Okay, so I'm going to go ahead and take a quick little screenshot of that, bring that over. That wasn't helpful, sorry. Okay, I'm going to put that right here. There we go. So big. So we're going to make this smaller. Thank goodness for technology, huh? All right, so hopefully you guys can use Desmos as a tool, but I don't want it to take away from your factoring skills because those are essential. All right, so let's do one more. This one is negative 2x squared plus 7x minus 5. 2x squared plus 7x minus 5. Okay, so go ahead. So if you can see, our y-intercept is 0, negative 5, and we have two x-intercepts as well. Remember I told you that that constant at the end of a parabola or a quadratic equation that's in standard form is always your y-intercept. No, control V, sorry. So this little guy is going to go over here. Again, I just want to give you guys this I don't mind walking you through this because I think a lot of learning can happen in these situations. Okay. Okay, so we have a couple of multiple choice, and then what else do we have? A couple more multiple choice. This is a long one. Sorry, guys. And then we'll take a look at this one, and we'll talk about the roots. So quadratic equation has three factors. Two factors are x minus 4 and x plus 2. Which of the following could be has three factors? It has two factors. Two of the factors are x minus 4 and x plus 2. If it had three factors, it wouldn't be a quadratic equation. So we know that our zeros are at x equals 4 and x equals negative 2. So we have x equals negative 2 and x equals 4 right here. So this would be the one. Okay. What are the solutions to this equation? Now again, I could always just plug these in and figure out where they cross the x-axis or where this equals 0, or I could factor it, but let's go ahead, just use our resources. Let's use Desmos. So this one is 2x squared plus 5x plus 3. So let's do 2x squared plus 5x plus 3. And let's zoom in. So we have two zeros here, 1 and negative 1.5, which is negative 3 halves, negative 1 and negative 1.5. So let's look. It would be, there we go, right here. Okay. All right, let's keep going. What are the real roots? Again, what are your x-intercepts? Again, so this would be, I would factor this as x minus 7 and x minus 2. So my two roots would be x equals 7 and x equals 2. Boom. Okay, so what are the solutions, guys? Solutions are your x-intercepts, your roots, everything. Okay, so they're all the same thing. So it's 2 and negative 1. Okay, which contains the zeros of this function. Okay, there's actually only two. All right, and this is a difference of 2 squares. So this is 3x minus 7 times 3x plus 7. So our zeros are going to be x is equal to negative 7/3 and x equals positive 7/3. Okay. Again, I don't mind if you use Desmos, but I do want you to be able to factor well. Okay. If there's anything I could tell you to always work on, solving equations and factoring. Okay. All right. Let's take a look at this fun little equation here. So we have the water after how many okay, so this is fantastic. When we do something like this, and I'm going to enter this on another thing, we have some peaks and valleys here, right? So we have some important things that we need to do in here. Now, again, whenever you're using Desmos, you have to use X instead of T, and also with a calculator too. So plus 16x, I'm going to bring it over in just a second, and then plus 480. Okay, so I'm going to zoom this way in, and because this is going to be really high, let's zoom out. Okay. Okay, so I'm going to bring this over here. So I want to show you a couple of things. So it at 480, it crosses so we want to find out what its maximum height is, right? Which is really what the vertex is. So what I'm going to do is click on this point right here. And after half of a second, it hits its maximum height, and that's at 484 feet. Okay, so that's what the vertex stands for. How long did it take? So let's just paste that here. There we go. So right here, what these mean, 0.5 seconds and 484 feet. These are taken from the vertex. And remember, the vertex of a parabola is either the maximum or the minimum. Because this is a negative in front, it's going to be facing down. So this becomes a maximum, okay? Then Jason hit the water after how many seconds? Well, I don't know. Let's find out. So let's find out. I'm going to keep zooming in here. I keep moving this because we want to find when it hits the water, the height is 0. So that gives us our x-intercept, right? So I'm going to keep going down. Sorry, guys. Holy smokies. Let's just go back home here. There we go. So it hits 0 after 6 seconds. So that is the x-intercept. So that's where it hits the ground. So that would be 6 seconds. Okay, I know this was a long test. I know it really stretched you. I know that some of the things that weren't directly covered, I thought I included a video in there and I didn't, and I apologize for that. But anyways, I hope this kind of makes up for it. And I hope it's helpful to you. I'm going to send this out. I'm going to post it on my YouTube channel, and thank you so much. You guys have been a great class. I've really enjoyed you. I really appreciate all of you. So have a great night. And remember to, if you do not have an A average and you have not passed your SOL, you will have to take the final exam next week. Okay?